This is some help with the setup for problem 8 on homework 7. So this is a linear programming application problem. The officers of a high school senior class are planning to rent buses and vans for a class trip. Each bus can transport 42 students and requires 5 chaperones and costs $1,000 to rent. And each van can transport 7 students, requires 1 chaperone, and costs $100 to rent. Since there are 588 students in the class that may be eligible for the trip, the officers must plan to accommodate at least that 588 students. And since only 75 parents have volunteered to serve as chaperones, the officers must plan to use at most 75 students. Okay, so greater than or equal to 588 students need to be accommodated, less than or equal to 75 need to be, less than or equal to 75 chaperones are available. We want to know how many vehicles of each type should they rent in order to minimize transportation costs. Now, the way that I would set this up is I would try to organize the information into a table like the other linear programming problems we've looked at. So the things that we're trying to find are the number of buses and the number of vans. So those are our two variables. So we could call buses X and then vans Y. So X is the number of buses, Y is the number of vans. And then we have some information related to students that would fit on the buses and the vans. And we have some information related to the chaperones that would fit on the buses and the vans. And we also have information about the cost of the buses and the vans. And we also know like the limits and the numbers of the students and the chaperones. So I'm just going to put total in this last column. Okay, so for the buses, we can fit 42 students on a bus. Okay, so 42 students times X, the number of buses. And we can fit 7 students on a van. So 7 students times however many vans we get. And we know that we need to accommodate the total number of 588 students. So the number of students on buses and the number on vans needs to be greater than or equal to 588. And then the chaperones, we need to have 5 on each bus. So 5 chaperones times the number of buses. And then we need 1 chaperone on each van, so 1 times the number of vans for the chaperones there. And we have at most 75 chaperones, so less than or equal to 75. And then the information that we have about the cost is that each bus is $1,000 to rent. So $1,000 times the number of the buses. And then each van is $100 to rent. So $100 times the number of van. Okay, so we could turn this into a linear programming problem where we're trying to minimize cost. So we're going to try to minimize the function cost, which is $1,000 per bus plus $100 per van. And we're going to try to minimize it subject to the 2 inequalities that we just wrote, or that we've kind of set up in this table. So the inequality that has to do with the students is that 42x plus 7y needs to be greater than or equal to 588. And related to chaperones, that 5x plus 1y is less than or equal to 75. Then we also have we can't have a negative number of buses or vans, so we also need the x greater than or equal to 0, y greater than or equal to 0 restrictions. So we'd graph these 2 inequalities, find the corner points, and then try to minimize this cost function, so make this cost function as small as possible.